Hello, we are team number 18, otherwise known as KAIKANA. Since our last video update in the fall of 2021, we have begun to build our modeled power system design and are currently in the process of receiving our materials to do so. Our design has been steadily altered as we grew into fruition for meeting our project's demands as closely as possible. I have been tasked with the final configuration and testing of our power system in a controlled environment. I will collect the final builds of my colleagues and implement them onto the main base of our constructed design. Because of the cost of assembling a true extraterrestrial setting in terms of a pressurized vacuum in space, we will instead be using a walk-in freezer to simulate our freezing conditions in outer space, where our project takes place. From there, I will attempt to collect data for our system's components.
Hi, my name is Jonathan. I designed and created simulations for the power electronics sides project. For the past few months, we have endured challenges that would need to be overcome user design demands. With the elimination of some of the components we gave during our proposal, with our extension budget from miscellaneous hardware to the entire enclosure being fabricated, it would need to be scaled back to meet most of the demands by building the entire lander. As most of our suppliers have seen a mass shortage of materials, we had to resort to other means of resolving from other components that are readily available and were cost efficient. I have obtained and soldered the conductors to the respective connectors and owned them out to each portion to ensure no issues were encountered during the soldering. With lead times increasing, power electronics simulation is complete in case parts have a longer lead time or we would unable to receive the parts for our final testing. I am still awaiting the PCB to be built and sent for my physical testing on my workbench. And until next time.
Hi, this is Robert, and I'm in charge of the thermal controller and data acquisition components of our prototype lander. I have received the RTD and microSD board and am currently integrating the RTD with the microcontroller and testing the output through Simulink. I've set up the RTD as a voltage divider, limiting the maximum current through the RTD, which led to good results, but slow at sensing temperature change. I will be trying a Wheatstone bridge to compare a voltage difference for more sensitivity. An amplifier might be needed. A FLIR camera will be used to compare the recorded data with observation. Next, I'll be moving forward with enabling storage of the collected data onto the connected microSD board. The PI thermal controller will be tested later when the power converter PCB arrives. Until this delivery, I will be using a relay component with an error comparator within Simulink to turn on off the heating element for testing of the controller. Thank you, and now on to my colleague, Sean.
Hi, I'm Sean Caldwell, and I will be working on our lander's Gauss meter, temperature sensor, and distance sensor. I have 2 Arduino Duos currently, which I'll be using for the assembly, and I'm waiting for 3 sensors to start my portion of the build. When I have my parts built, tested, and I can verify that they do what we need them to do for our system, then I'll send them out to Victor, who is handling the final assembly. I'll also document and draw wiring diagrams for all my parts so that we can have a good understanding of how everything works, and Victor can know what to do in the case that we have shipping issues and anything gets damaged. Again, we're Team 18, KAIKANA, and we'll catch you next time.